Now, in this lecture, we'll find out the maximum area of a rectangle that is inside a triangle. In the drawing, we have triangle ABC. We know that side AB of the triangle ABC equals to 10 units in itself, side AC equals to 17 units in itself. This is side BC, that is equals to 21 units in itself. Inside this triangle ABC, we have this rectangle PQST, and our mission is to find out the maximum area of this rectangle PQST. So in the first step, we do a construction, that is to say from point A, we will do perpendicular on PQ. Again, from point A, we will do perpendicular on PQ. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A inside PQ as M. In the next step, we'll extend the perpendicular AM by a straight line until it touches side BC. And we define the touching point of the extended perpendicular AM inside BC, this point is N. Okay. By doing this construction, we get those two corresponding angles. Those two angles are defined as corresponding angles, and they are located between the two parallel lines PQ and BC, and therefore they are equal to each other. But this angle equals to 90 degrees, therefore this angle must also equal to 90 degrees. Likewise, those two angles are also defined as corresponding angles, and they are located between the same two parallel lines PQ and BC, and therefore they must be also equal to each other according to the same rule. But this angle equals to 90 degrees, therefore this angle must be also equal to 90 degrees in its size. In the next step, we define the length of this line segment BN as x. Okay? Yeah. BN equals to x according to our definition. So what is the length of line segment NC? From the drawing it is very easy to see that NC equals to BC minus BN. Again, NC equals to BC minus BN. BC minus BN. So write it down. The length of line segment NC is equals to BC minus BN. So NC equals to BC. BC is 21 according to this given equation, minus BN. BN is x according to our definition. So in total we shall find out that NC equals to 21 minus x. The length of line segment NC equals to 21 minus x units. So here NC, this line segment NC equals to 21 minus x units in its length. In the next step, I'll copy this right triangle A and C in the new page, and we will implement the Pythagoras theorem on this right triangle A and B. According to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is the relation for Pythagoras theorem. The hypotenuse AB of the right triangle A and B equals to 10 units in itself, according to what's given as the question. Side BN equals to X, according to our definition. So actually, this is the right triangle A and B that are going to the window domain. According to the Pythagoras theorem, in this right triangle A and B, AB squared, that is the square of the hypotenuse, equals to NB squared plus AN squared. This is equation 1. Here we subtract NB squared from this equation 1. And we get that according to this equation 1, AN squared equals to AB squared minus NB squared. So according to equation 1, AN squared equals to AB squared. AB is 10, therefore AB squared is 10 squared, that is 100, minus NB squared. NB, according to our definition, equals to X, therefore NB squared is X squared. So in conclusion, we found out that according to equation 1, AN squared equals to 100 minus X squared. In the next step, I'll copy this right triangle A and C. This right triangle A and C in the new page, and we implement the Pythagoras theorem on this right triangle A and C. The hypotenuse AC equals to 17 units in itself, according to what is given as the question. Side NC equals to 21 minus X. Here by PT is the version for Pythagoras theorem. So actually, this is the right triangle A and C that are going from the original drawing. According to the Pythagoras theorem, in this right triangle A and C, AC squared, that is the square of the hypotenuse, equals to NC squared plus AN squared. Okay, so here we subtract NC squared from this equation 2, and we get that according to this equation 2, AN squared equals to AC squared minus NC squared. So AN squared equals to AC squared. AC is 17, therefore AC squared is 17 squared, it is 289. Minus NC squared. NC is 21 minus X, therefore NC squared is 21 minus X squared. So according to equation 2, if we found out that AN squared equals to 289 minus 21 minus x squared. This is according to equation 2, while according to equation 1, we have already found out that an squared equals to 100 minus x squared. So we have two different equations for the value of an squared. Therefore, we get equation 3 that says that an squared according to equation 1 must be equal to an squared according to equation 2. So an squared according to equation 1 is 100 minus x squared, and it must be equal to an squared according to equation 2. An squared according to equation 2 equals to 289 minus 21 minus x squared. According to equation 3, we actually found out that minus x squared, that is an squared according to equation 1, equals to 289 minus 21 minus x squared, that is an squared according to equation 2. So here we'll open the brackets of this expression 21 minus x squared, and we get that according to this equation 3, this side of equation 3 we have 100 minus x squared, and it is equals to, on the other side of this equation 3, we have here 289, and we have here minus 21 minus x squared. 21 minus x squared equals to 21 squared, that is 441, plus x squared minus 2 times 21 times x. Minus 2 times 21 times x is minus 42x. So according to equation 3, we actually found out that 100 minus x squared equals to 289 minus, and inside the brackets we have 441 plus x squared minus 22x. Here we open the brackets here in this expression, and we get that according to this equation 3, 100 minus x squared equals to, here we have 289, here we have minus, so we open the brackets here. After we open the brackets, this expression will be equal to minus 441 minus x squared, and there we minus times minus is plus, so it is minus 42x is plus 42x. So according to equation 3, we actually found out that 100 minus x squared equals to 289 minus 441 minus x squared plus 42x. So here we have both sides of this equation 3 minus x squared, so minus x squared will get cancelled, and after we get cancelled minus x squared, in this side of equation 3 we left only with 100, and the other side of the equation 3 we have 289 minus 441 plus 42x. So according to equation 3, we actually found out that 100 equals to 289 minus 441 plus 42x. Here we add to this equation 3, 441, and you get that according to this equation 3, 441 plus 100 is 541, and is equals to 289 plus 42x. So here we subtract 289 from this equation 3, and so you get that 541 plus 289 equals to 252, so 252 equals to 42x. So here we divide this equation 3 by 42, and finding it that according to this equation, equation 3, x equals to 252 over 42. 252 over 42 equals to 6. So it shall find out that x equals to 6 units in its length. So actually, side Bn is equal to x is equal to 6 units. And then also side NC that is equal to 2116 is 2116, that is 15. In the next step, we return to the first equation. According to equation 1, we found out that an squared equals to 100 minus x squared. But x is 6, therefore x squared is 6 squared, that is 36. So in total, according to equation 1, an squared equals to 100 minus x squared is minus 36. 100 minus 46 is 64. So we found out that according to equation 1, an squared equals to 64. Here we take out all of this equation 1, we get that an squared equals to 64, so an equals to the square root of 64, that is 8. So an equals to 8 units in its length. So an equals to 6 units in its length. I write it down here. An equals to 8 units in its length. Again, an equals to 8 units in its length. The next step, we define the width of this rectangle PQST. The width is QS. We define the width that is QS as B. So QS equals to B according to our definition. And we define the length PQ of this rectangle PQST as A. So PQ equals to A according to our definition. And the width QS equals to B. Here, those two angles are defined as corresponding angles, and they are located between the parallel lines PQ and BC, and therefore they are equal to each other. So if this angle is alpha, then this angle must be also equal to alpha, because those two angles are equal to each other. Likewise, those two angles, this is angle ACB is equals to this angle, this is actually angle AQP. So those two angles, they are both defined as corresponding angles, and they are located between the two sub-parallel lines QP and BC, and therefore they are equal to each other. So if this angle is beta, then this angle must be also equal to beta, because they are equal to each other. Okay, so in the next step, we prove that the big triangle ABC is similar to the small triangle APQ. Okay, so why the big triangle ABC is similar to the small triangle APQ? First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to beta, therefore they are equal to each other. And finally, this angle is angle A. It is a common angle that belongs to both triangles, so we can write down angle A equals to itself as a common angle that belongs to both triangles. So we found out that all the three angles of the big triangle ABC are correspondingly equal to all the three angles of the small triangle APQ, and therefore those two triangles are similar to each other according to angle similarity rules. So write it down. We found out that the big triangle ABC is similar this is the sign of similar to the small triangle, triangle APQ. According to angle similarity rule. Actually, whenever you have two similar triangles, then the ratio between heights is equal to the ratio between sides. Again, that is to say, when you have two similar triangles, then the ratio between their corresponding sides must be equal to the ratio between their corresponding heights must be equal to the ratio between their corresponding sides. So so we found out that the big triangle ABC is similar to the small triangle APQ, and therefore, according to what I mentioned 1 second ago, it means that the height AM of the small triangle APQ over the height AN of the big triangle ABC, again, the height AM of the small triangle APQ over the height AN of the big triangle ABC must be equal to the ratio between their sides. It must be equal to side PQ of the small triangle APQ over side BC of the of the big triangle ABC. Repeat again. AM over AN is the ratio between the corresponding sides of the two similar triangles ABC and APQ, and it must be equal to the ratio between their corresponding sides, that is PQ over BC. So okay, in conclusion to equation 1, we actually found out that AM over AN equals to PQ over BC. But what is the length of side AM? Actually, we know that AN, okay, but before that, we focus on, we know that PQST is a rectangle, and we know that all the angles in any rectangle are right angles. So this angle equals to 90 degrees in each side, and this angle also equals to 90 degrees in its sides, because those two angles, there are two angles out of the four angles inside rectangle PQST, and therefore each of them must be equal to 90 degrees in its size. So we will focus on this quadrilateral MQSN. In this quadrilateral, the small quadrilateral MQSN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. So inside this small quadrilateral NMQS, we have 4 right angles, and according to rule 6, any quadrilateral that has 4 right angles must be this rectangle, if not a square. So we relate to this quadrilateral MQSN as a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle MQSN, side QS must be equal to the opposite side MN. But QS is B, therefore MN must be also equal to B. So what is the length of side AM? From the drawing it is very easy to see that AM equals to AN minus MN. Again, AM equals to AN minus MN. So write it down. AM equals to AN minus MN. So AM, this is with AM equals to AN. AN is 8 minus MN. We just found out that MN equals to B. So in total, we found out that AM equals to 8 minus B. This times with AM equals to 8 minus B. Now, we return to equation 1. We found out that because of the fact that the big triangle ABC is similar to the small triangle PQ, the following equation is true, that AM over AN equals to PQ over BC. We just right now found out that AM equals to 8 minus B, therefore we substitute AM in this equation 1 by 8 minus B over AN. AN equals to 8 units in itself, so we substitute AN by 8. And it is equals to PQ. PQ is the length of this rectangle PQST, and according to our definition, the length of this rectangle PQST equals to A. Therefore, we substitute PQ by A over BC. BC is 21 according to what is given as the question. Therefore, we substitute BC by 21. In conclusion, we actually found out that according to equation 1, 8 minus B over 8 equals to 8 over 21. Here we cross multiply this equation 1, and we found out that according to this equation 1, 8A equals to 21 times 8 minus B. Here we divide this equation 1 by 8, and finally we get that according to this equation 1, A equals to 21 over 8 times 8 minus B. So here we'll open the brackets on this side of this equation 1, and get that according to this equation 1, A equals to 21 times 8 over 8 is 21, and here 21 over 8 times minus B equals to 20 minus 21B over 8. So according to equation 1, we actually found out that A equals to 21 minus 21 over 8 times B. A, it is actually the length of this rectangle PQST. The length PQ equals to 8. So A is the length of this rectangle PQST. So we have equation for the length of rectangle PQST. A equals to 21 minus 21 minus B over 8. That is to say, if we found out the value of B, we immediately know what is the value of A, because we just substitute B by the value that we found for B, and we put the value of B inside this equation, and we get the value of A. So if we know the width of the rectangle, we immediately know also the length, because A equals to 21 minus 21 times B over 8. So here we multiply this equation 1 by B, and we get that according to this equation 1, A times B equals to 21B, and minus 21 over 8 times B, minus 21 over 8 B times B is minus 21 over 8 times B squared. What is A times B? A is the length, B is the width. And the length times the width is the area of this rectangle PQST. Repeat again, the length times the width of this rectangle PQST must be equal to the area of this rectangle PQST. So actually found out the function area of this rectangle PQST. And the area of rectangle PQST, that is A times B, equals to 21 times B minus 21 over 8 times B squared. Our mission is to find out the maximum area of the rectangle PQST. Or in other words, our mission is to find out the maximum value of this function area. Okay? Because the maximum value of this function area is the maximum area of this rectangle PQST. Why? Because the area equals to AB. Therefore, the maximum value of this function area will be the maximum area of this rectangle PQST. In order to find out the maximum value of this function, we have to differentiate this function, and we will equate the derivative of this function to 0. In this way, we find out the maximum, the extreme point of this function area, and then we draw this function area. We will do a graph of this function area in order to verify that the extreme point that we found is maximum extreme point and not minimum extreme point. So first of all, we differentiate this function area. This is why we take the derivative of this function area. D is the equation for derivative. So we take the derivative of 21b minus 21 over 8 b squared. And we differentiate this function area according to the variable b. So the differentiations will be done according to the variable b. So it is d, the derivative of this function a 21b minus 21 over 8 times b squared according to the variable b. So the variable that we are going to differentiate is b. This is the independent variable in this function area. And the dependent variable is the area itself, because when we determine the value of b, the value of the area will be determined immediately by the value of b. Okay. So what is the derivative of 21b minus 21b squared over 8? Actually, the derivative of b is 1, and therefore in total this expression will be equal to 21 times 1, that is 21. In conclusion, we found out that the derivative of 21b is 21. And what is the derivative of this? The derivative of this expression minus 21 over 8 times b squared. Actually, we know that the derivative of b squared is 2b, and therefore the derivative of this expression in total will be equal to minus 21 over 8 times 2b. And we have to equate this derivative to 0 in order to find out the extreme point of this function area. The extreme point or the extreme point or the extreme point of this function area. So in conclusion, we found out that the derivative of this function area equals to 21 minus 21 over 8 times 2b, and then we equated this derivative to 0 in order to find out the extreme point of this function area. After we find out the extreme point of this function area, I will draw the graph of this function area in order to verify that the extreme point that we found is indeed maximum extreme point and not minimum extreme point. So first of all, we will solve this equation in order to find out the extreme points of the function area of rectangle PQST. So here we'll take 21 as a second factor out of those two expressions. So what is left from 21 of 32 forming 21 is a common factor. What is left is actually 1. And what is left from this expression minus 21 over 8 times 2b of 32 forming 21 is a common factor. What is left is actually minus 2b over 8. And it is equals to 0. So here we divide this equation 2 by 21. And we get that according to this equation 2, 21 over 21 is 1, so in this side of the equation we left only with 1 minus 2b over 8, and it equals to, here 0 over 21 is 0. So according to equation 2, we found out that 1 minus 2b over 8 equals to 0. Here we relate 2b over 8 to this equation 2, and we get that according to equation 2, this equation 2, 1 equals to 2b over 8. So here we divide both the numerator and the denominator of this expression by 2. And we get that according to this equation 2, 1 equals to 2b over 2 is b, and 8 over 2 is 4. So we actually found out that 1 equals to b over 4. Repeat again, we actually found out that according to equation 2, 1 equals to b over 4. Here we multiply this equation by 4, and we get that according to this equation 2, b equals to 4 units in its length. This is to say, the extreme point of the function area is b equals to 4. Repeat again, the extreme point of this function area that is there of rectangle PQST is b equals to 4. Now we have to draw the function area in order to verify that when b equals to 4, then the area is its maximum value and not in its minimum value. Because when you have extreme point, the extreme point could be maximum extreme point and also minimum extreme point. So actually, this is the function area of rectangle PQST. The function area is AB. AB is the area of rectangle PQST. That is equal to 21b minus 21 over 8 times b squared. This is the graph of this function area. In the y-axis we have the area, that is a times b. In the x-axis we have the width, that is b. Again, in the x-axis we have the value of b, that is the width of this rectangle PQST. And in the y-axis we have the value of the area. And here, when b, that is the width of this rectangle PQST, when b equals to 4, here when b equals to 4, the area of rectangle PQST is at this point. That is to say, it is in its maximum height, or it is in its maximum value. Here, this point, we have here, it is a little bit above of 40. This number is 40. So when the width of rectangle PQST equals to 4 units in itself, then the area is in its maximum value, that is a little bit above of 40 square units. In this way, we actually verified that the extreme point that we found, that is b equals to 4, is indeed maximum extreme point and not minimum extreme point. In this way, we actually solved the question. So when b equals to 4, the area of rectangle PQST is in its maximum value. In order to find out what is the maximum area when b equals to 4, we just have to substitute b by 4 the function area. The function area of rectangle PQST is A times B. Again, A times B is the area of rectangle PQST, and this equals to 21B minus 21 over 8 B squared. Now we have to substitute B by 4, and in this way we find out the maximum area of rectangle PQST, that is the area that we are looking for. So B equals to 4, we substitute B by 4 in this function area. When B equals to 4, the area AB, that is the maximum area, equals to 21 times B, it's 21 times 4, 121 over 8 times B squared. B is 4, therefore B squared is 4 squared, it is 16. So actually found out that the maximum area of rectangle PQST is 21 times 4, that is 84. What is the value of this expression? Here we have 16 over 8 is 2. So in total the value of this expression is 2 times minus 21, that is minus 42. So in total we found out that the maximum area of rectangle PQST equals to 42 to 84 minus 42, that is 42. So the answer to the question is that the maximum area of this rectangle PQST that is located inside this triangle ABC is equal to 42 square units. Okay, so write it down. The maximum area mass of rectangle PQST is equal to 42 square units. And when the maximum area equals to 4, then the width B, when the maximum area equals to 42 square units, then the width B is 4, and the length A is 21 minus 21 over 8 times B. We have to substitute B by 4, and we get that A equals to 21 minus 21 over 8, and B is 4, so we substitute B by 4. So the length in total equals to 21, and here we have minus 21 times 4 over 8. Here we divide both the numerator and the denominator by 4, so we equal to here 21, and in the numerator we left with minus 21 after we divided by 4. In the denominator we have 8 over 4 is 2. So in total the length A equals to 21, and minus 21 over 2 is minus 10.5. 21 minus 10.5 equals to 10.5. So we should find out that when the maximum area of this rectangle PQST equals to 42 square units, then the width B equals to 4, and the length A equals to 10.5 units. So you can see that A times B is 10.5 times 4, that is 42 square units. Okay, so we found out that the maximum area of this rectangle PQST equals to 42 square units, and then when the maximum area equals to 42 square units, the width B is 4, and the length A is 10.5. So in the next step, I'll summarize the lecture. In this lecture, we found out the maximum area of this rectangle PQST that is located inside this triangle ABC. So, in the drawing, we have triangle ABC. Side AB of this triangle ABC equals to 10 units inside. Side AC equals to 17 units inside. This is side BC that is equals to 21 units inside. Inside this triangle ABC, we have this rectangle PQST. And I repeat again, our mission is to find out the maximum area of this rectangle PQST. In order to find out the maximum area of this rectangle PQST, we did a construction. That is to say, from point A, from the vertex A of triangle ABC, we draw perpendicular on PQ. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and PQ, this point is M. The next step, we extended the perpendicular AM by straight line until it touches side BC, and we find the touching point of the extended perpendicular AM with side BC, this point is M. By doing this construction, we created here two corresponding angles, and we have the rule that corresponding angles between parallel lines are equal to each other. So those two angles, they are located between the parallel lines PQ and BC, and therefore they are equal to each other. So those two angles are equal to each other. But this angle equals to 90 degrees according to our construction. Therefore this angle must be also equal to 90 degrees, so they are equal to each other. Likewise, those two angles are also defined as corresponding angles, and they are located between the same parallel lines PQ and BC, and therefore they are equal to each other. But this angle equals to 90 degrees according to our construction. Therefore this angle must be also equal to 90 degrees. In the next step, we defined this line segment BN as X. What is the ref of NC? From the domain, it is very easy to see that NC in total equals to BC minus BN. Again, BC minus BN equals to NC. So NC equals to BC, that is 21 according to all this equation, minus BN, that is X according to our definition. So in total, this line segment NC equals to 21 minus X. In the next step, I copied this right triangle A and B in a new page, and we implemented the Pythagoras theorem of this right triangle A and B. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. This is the right triangle A and B that I copied from the original drawing. In this right triangle A and B, the hypotenuse AB equals to 10 units in itself according to what is given as the equation, and side BN equals to X according to our definition. So in this right triangle A and B, according to the Pythagoras theorem, AB square equals to BN square plus AN square. Again, AB square equals to NB square plus AN square. Here we subtracted NB square for this equation. We found out that according to this equation 1, AN square equals to AB square minus NB square. So AN square, this is the missing side, equals to AB square. AB is 10, therefore AB square is 10 squared, that is 100. Minus NB square. NB is X, therefore NB square is X square. So in conclusion, according to equation 1, we found out that AN square equals to 100 minus X square. In the next step, I copied this right triangle ANC in a new page, and we implemented the Pythagoras theorem in this right triangle ANC. This is the right triangle ANC that I copied from the original drawing. The hypotenuse AC equals to 17 units in itself according to what is given as the question. We have already found out that side NC equals to 21 minus X. So in this right triangle ANC, according to the Pythagoras theorem, AC square equals to NC square plus AN square. Again, AC square equals to NC square plus AN square. We subtracted NC square from this equation, and we found out that according to equation 2, this equation 2, AN square equals to AC square minus NC square. So AN square equals to AC square. AC is 17, therefore AC square is 17 square, that is 289. Minus NC square. NC equals to 21 minus X, therefore NC square equals to 21 minus X square. So according to equation 2, we actually found out that AN square equals to 289 minus 21 minus x squared. This is according to equation 2. According to equation 1, we have already found out that an squared equals to 100 minus x squared. So we have two different equations for the value of an squared. Therefore, we get that equation 3 that states that an squared according to equation 1 must be equal to an squared according to equation 2. So, according to equation 3, an squared according to equation 1 is 100 minus x squared, and it must be equal to an squared according to equation 2. And an squared according to equation 2 is 289 minus 21 minus x squared. So according to equation 3, in conclusion, we found out that 100 minus x squared equals to 289 minus 21 minus x squared. We open the brackets of this expression, that is 21 minus x squared, and found out that according to this equation, equation 3, 100 minus x squared equals to 289 minus, and here we have 21 minus x squared equals to 21 squared, that is 441, plus x squared minus 221 times x is minus 42x. So here we open the brackets of this expression. We have minus before this expression, and found out that 100 minus x squared equals to 289. So we open the brackets, and this expression, after we open the brackets, will be equal to minus 441 minus x squared, and we have minus times minus is plus, so it is plus 42x. So according to equation 3, we actually found out that 100 minus x squared equals to 289 minus 441 minus x squared plus 42x. Here we have x squared on both sides of the equation, so x squared will get cancelled. After we cancel x squared, in this side of the equation we left only with 100, in the other side of the equation we left with 289 minus 441 plus 42x. Here we added 441 to this equation, equation 3, and found out that according to this equation, equation 3, 441 plus 100 is 541, and 541 equals to 289 plus 42x. Here we subtract 289 from this equation, equation 3, and found out that according to this equation, equation 3, 541 minus 289 is 252. So 252 equals to 42x according to this equation, equation 3. Here we divided this equation, equation 3 by 42, and finally found out that x equals to 252 over 42 is 6. Again, 252 over 42 is 6. So x equals to 6 units inside. That is to say, the length Bn, that is x, is equals to 6 units, and the length Nc, that is 21 minus x, is 21 minus 6, that is 15. In the next step, we return to equation 1. According to equation 1, we actually found out that an squared equals to 100 minus x squared. So an squared equals to 100 minus x squared. X is 6, therefore x squared is 6 squared, it is x squared is 6 squared, that is 36. So according to equation 1, we actually found out that an squared equals to 100 minus 36, that is 64. So an squared equals to 64. We took out of this equation, and finally found out that an equals to the square root of 64, that is 8. So this line 7 an equals to 8 units in length. Here an equals to 8. In the next step, we defined the width of this rectangle PQST, that is to say, the width PQ as B, and we defined the length, that is AQ, of this rectangle PQST as A. So PQ equals to A according to our definition, and the width QS equals to B also according to our definition. So here we know that PQST is a rectangle, and we know that all the angles inside any rectangle are right angles. So those two angles, there are two angles out of all angles inside this rectangle PQST, and therefore they are right angles. In the next step, we focus on this quadrangle MQST. Inside this quadrangle MQST, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle. In total, they must be equal to 360 degrees. according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its side. So inside quadrilateral, this one quadrilateral MQS, and we have 4 right angles. And according to rule 6, any quadrilateral that has 4 right angles must be at least a right angle, if not a square. So we learn to this quadrilateral MQSN that has 4 right angles is a right angle. But we also know that the opposite sides of right angle are equal to each other. So in this 4 right angle MQSN, side QS must be equal to the opposite side MN. But QS is B, therefore MN must be also equal to B. So what is the length of AM? From the norm it is very easy to see that the length of line segment AM is AN minus MN. Again, AM equals to AN minus MN. So AM equals to AN, that is 8, minus MN, that is B. So in total, AM equals to 8 minus B. Okay. Here, those two angles, they are defined as corresponding angles, and they're located between the parallel lines PQ, and they're located between the parallel lines PQ and BC, and therefore they are equal to each other according to the rule that corresponding angles between parallel lines are equal to each other. So those two angles are equal to each other. So if this angle is alpha, then the angle must be also equal to alpha because those two angles are equal to each other. Likewise, those two angles are also defined as corresponding angles, and they are located between the same parallel lines QP and BC, and therefore they are equal to each other. So if this angle is beta, then the other angle must be equal to beta also because those two angles are equal to each other. In the next step, we proved that the big triangle ABC is similar to the small triangle APQ. Why the big triangle ABC is similar to the small triangle APQ? First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to beta, therefore they are equal to each other. And finally, this is angle A, that is a common angle, it belongs to both triangles, so we can learn down that angle A equals to itself as a common angle that belongs to both triangles. So in conclusion, we shall find out that all the triangles of the big triangle ABC are correspondingly equal to all the triangles of the small triangle APQ, and therefore those two triangles are similar to each other according to angle similarity rule. And again, the big triangle ABC is similar to the small triangle APQ according to angle similarity rule. And whenever you have two triangles that are similar to each other, then the ratio between their heights must be equal to the ratio between their sides. That is to say, the ratio between their corresponding heights must be equal to the ratio between corresponding sides. So in those two similar triangles, ABC and APQ, it means that the height AM in the small triangle APQ over the height AN in the big triangle ABC must be equal to side PQ of the small triangle APQ over side BC of the big triangle ABC. Repeat again, we derive from the fact that the big triangle ABC is similar to the small triangle APQ, that AM over AN, that is the height between the corresponding heights of those two triangles, is equal to the ratio between their corresponding sides. And their corresponding sides are PQ and BC. So according to equation 1, we should find out that AM over AN equals to PQ over BC. AM is 8 minus B, AN is 8. Again, AM is 8 minus B, AN is 8. PQ is A according to our definition, and BC is 21 according to what is given as the question. Again, PQ is A and BC is 21. So in conclusion, according to equation 1, we actually found out that 8 minus B over 8 equals to A over 21. Here we can multiply this equation in equation 1, and finally found out that according to this equation 1, 8A equals to 21 times 8 minus B. Here we divided this equation 1 by 8, and finally found out that according to this equation 1, A equals to 21 over 8 times 8 minus B. Again, A equals to 21 over 8 times 8 minus B. This is according to equation 1. Here we opened the brackets on this side of this equation 1, and finally found out that A equals to 21 over 8 times 8 is 21, and 21 over 8 times minus b is minus 21b over 8. Okay, so here we multiplied this equation 1 by b, and we found out that according to equation 1, a times b equals to 21b, and minus 21b over 8 times b is minus 21b squared over 8. So in conclusion, according to equation 1, we actually found out that a times b equals to 21b minus 21b squared over 8. But what is a times b? A is the length and b is the width of this rectangle PQST, and the length times the width is the area of this rectangle PQST. So a times b is the area, and the area equals to 21b minus 21 over 8 times b squared. So we should found out the area of this rectangle PQST according to the variable b. The b is the width, that is the variable in this function area. The independent variable on this function area, ab equals to 21b minus 21 over 8 times b squared. And our mission is to find out the maximum area of this rectangle PQST. Or in other words, our mission is to find out the maximum value of this function area, that is to say, for which b the value of AB will be maximum, or for which b the area will be maximum, because a times b is the area. In order to find out for which b the area of this function area is its maximum value, we have to differentiate this function area, and then we will equate the derivative of this function area to 0. So the derivative of 21b minus 21 over 8b squared is d. It is a relation for derivative. We have to take the derivative of 21b minus 21b squared over 8, that is the function area of this rectangle PQST. And then we will equate this derivative to 0 in order to find a maximum, in order to find the extreme points of this function area. And then we will have to draw the function area, to do the graph of this function area, in order to verify that the extreme point that we found is indeed maximum extreme point or not minimum extreme point. So what is the derivative of 21b? The derivative of b is 1, and therefore this expression in total equals to 21 times 1, that is 21. So the derivative of 21b is 21. And what is the derivative of minus 21 over 8b squared? Actually, the derivative of b squared is 2b, and therefore in total the derivative of this expression will be equal to 21 over 8 times 2b. And the derivative in total equals to minus 21 over 8 times 2b. So in total, the derivative of the function area of the area of rectangle PQST equals to 21 minus 21 over 8 times 2b. And then next step, we have to equate this derivative to 0 in order to find extreme points in the area function. So we equated the derivative to 0. Then we took 21 as a common factor of those two expressions. So what's left from 21 after we took from it 21 as a common factor? What is left is actually 1. And what is left from this expression minus 21 over 8 times 2b after we took from it 21 as a common factor? What is left is actually minus 2b over 8. and it is equals to 0. Here we divided this equation 2 by 21. So 21 over 21 is 1, so we left in this side of the equation only with 1 minus 2b over 8. And the other side of the equation we have 0 over 21 is 0. So according to equation 2, we actually found out that 1 minus 2b over 8 equals to 0. Here we added 2b over 8 to this equation, equation 2, and finally found out that according to this equation, equation 2, 1 equals to 2b over 8. Here we divided both the numerator and the denominator of this expression by 2. So 2b over 2 is b, and 8 over 2 is 4. So in total, we found out that 1 equals to b over 4. Here we multiplied, here 1 equals to b over 4. Here we multiplied this equation 2 by 4, and finally found out that b equals to 4 units since then. So the extreme point of this function area, the extreme point of the function area of this rectangle PQST is 4. That is to say, the width b equals to 4. When the width b equals to 4, the area function of this rectangle PQST is in its extreme point. Now we have to verify that the extreme point that we found is indeed maximum extreme point and not minimum extreme point. That is to say that for when b equals to 4, then the area is in its maximum value and not in its minimum value. In order to find out that when b equals to 4, the area of this rectangle PQST is in its maximum value, we have to draw the graph of this function area of the rectangle PQST. This is the graph of the function area of this rectangle PQST. The function area is a times b, that is the area of rectangle PQST. This is equal to 21b minus 21 over 8 times b squared. In the y-axis we have the area, in the x-axis we have the width b. And you can see from this graph, this is the graph of the function area of rectangle PQST, that when b equals to 4, then the area in its maximum value on its maximum height. When b equals to 4, then the area is a little bit greater than 40. This number is 40. So in this way we verified that the extreme point b equals to 4 is indeed maximum extreme point and not minimum extreme point. Now the only thing that is left to do is to put the value of b equals to 4 inside this function area and to find out what is the maximum area of this rectangle PQST when b equals to 4. Again, the function area of this rectangle PQST is AB, that is the area of rectangle PQST, is equal to 21 times b minus 21 over 8 times b squared. Now we have to substitute b by 4 in this function area. So we did it and we found out that AB equals to 21b and b is 4, therefore it is 21 times 4 minus 21 over 8 times b squared. B is 4, therefore b squared is 4 squared, that is 16. So in total we actually found out that the maximum area of this rectangle PQST is 21 times 4, that is 84. And here we have, what is the value of this expression? We have here 16 over 8 is 2. So in total the value of this expression is 2 times minus 21, that is minus 42. So the maximum area of this rectangle PQST equals to 84 minus 42, that is 42. Okay, again, the maximum area of this rectangle PQST is 42 square units. Okay, and again, the maximum area of rectangle PQST is 42 square units, and when the maximum area is 42 square units, then the width of the rectangle is 4 units, and the height A is 21. The height A is 10.5. how do we know that the height A equals to 10.5? Because we put the value of 4 in the equation for A equals to 21, here A equals to 21 minus 21 over 8 times B. If we substitute B by 4, we get that A equals to 21 minus 21 times 4 over 8. So it is 21 minus 21. Here we divided both the numerator and the denominator by 4, and we get that A equals to 21 minus 21 over 2. 21 over 2 is 10.5. So the length A is equals to 21 minus 10.5, that is 10.5. So when the maximum area of this rectangle PQST is equals to 42 square units, then the length B is 4, and the width B is 4, and the length A is 10.5 units. And A times B, A is 10.5, B is 4, so it is 10.5 times 4, that is 42 square units. In conclusion, we found out that the maximum area of this rectangle PQST is equals to 42 square units. Okay, thank you very much.